In the last video, we were looking at recipes from sallysbakingaddiction.com, which, by the way, I realized after the last video, she's actually rebranded to Sally's Baking. She's not addicted anymore, so just Sally's Baking. Sorry for the confusion. So let's revisit that table from last time. We looked at recipes that were either dessert recipes or other, and then we also noted if they had chocolate in them or no chocolate. If I randomly select one, the probability that it is a recipe that involves chocolate is 14 out of 36. But if I randomly select one and I tell you, hey, it's a dessert recipe, this changes the probability that it's about chocolate. If I tell you that the recipe is a dessert recipe, now we're not thinking of all 36, we're narrowing it down to just the 21 dessert recipes. So if you know that it's dessert, the probability that it's a chocolate recipe is actually 12 out of 21 instead of 14 out of 36. Editing me will put the percents here just to make it more obvious. Knowing that it is a dessert recipe increases the chance that it has chocolate in it, which makes sense. This is called a conditional probability. The symbol that we use is a straight up and down line, which basically means given. So what I asked you was, what's the probability that the recipe involves chocolate, given that it is a dessert recipe? We can do the reverse as well. What's the probability that the recipe involves chocolate, given that it's an other recipe? For this, we would look out of the others, which was 15. Only 2 of those others had chocolate in it, so 2 out of 15. So the given changes the bottom of the fraction, or the denominator of the fraction. If we're just looking at the probability that a recipe is chocolate, we're looking at out of everybody. Given that it's a dessert recipe, we're looking out of the 21 dessert recipes. Given that it's not dessert, we're looking at the 15 non-desserts. The events has chocolate and is a dessert recipe would be independent if this was true. If the probability of a recipe being a chocolate recipe was equal to the probability of it being chocolate given that it's dessert. Okay, independent means that the two events do not affect each other. So if this is true, it basically means that knowing the recipe is a dessert recipe does not change the probability that it's a chocolate recipe. Now, in this case, this fact wasn't true. The events is a chocolate recipe and is a dessert recipe. Those are dependent or not independent, if you want to say that. Common sense would tell us that desserts are more likely to have chocolate in them than non-desserts. So it does seem like these two events influence each other. Another example would be, let's just say random students are walking into my classroom and I'm supposed to guess before they enter the room if they have a driver's license or not. If the students are all students at my school, I'm probably like flipping a coin. Probably the upperclassmen have their driver's license and the underclassmen don't, so it's like a 50-50 guess. But if you tell me that the next student walking in is a freshman, well, then I'm changing my guess to no, they don't have a driver's license. And vice versa, if you tell me that the next kid walking in is a senior, I'm going to guess they have their license. So grade level and having a driver's license, those would be not independent, because knowing someone's grade kind of influences if they're going to have a license or not. So this is the formula for calculating conditional probabilities. The probability of A given that B has already happened. You take the probability of A and B and you divide by just the probability of B. This formula is useful, but I think if you have the table like we saw at the beginning, you don't really need the formula. Like, you were able to do all of those calculations at the beginning just with the table. You just focused on a different column each time, whether it was the total, the dessert column, or the other column. But formulas can be useful every now and then, so I will show you the formula just so you have it. Okay, enough talking about recipes. I want to actually bake something. So stick around for the next video because we're going to bake with probability. This might be a bad idea.